All right. Hello, everyone. Thank you for attending my talk on call quality assurance with Rasa and I2C. My introduction, I'm a machine learning engineer at Boomtown since the May of this year. Before that, I worked in conversational AI and dialogue systems at I2C as a data scientist for almost 2 years. And then I also do a bunch of other stuff that's probably not relevant in this discussion, but you can read it. Okay, so let's start off with what makes this talk unique. Well, that would be our business use case, that is call quality assurance. I2C is a payment processing firm where clients are banks, and we offer them services which include consumer and payment management, as well as customer support at I2C's call centers. In addition to customer support, we also offer them performance evaluation of these customer services, which includes tracking some key performance indicators that monitor an agent's behavior through his sentiment, active listening skills, whether or not he's following the script or policies, if he's placing customers on hold for too long, and most importantly, whether or not he's answering all of the customer queries correctly. So all of these things are evaluated per CSR manually on a random selection of calls on some time duration, like maybe a few calls a month or once a week. Each of these high-level categories are actually broken down into more and more granular rules that are shared between our banking customers, agents, and evaluators, and they can also vary based on your requirements or requests as a customer. So our solution to this in terms of AI was to use the call audios and the metadata that goes along with it inside the call, like the customer's profile, any actions that the CSR performs during the call, and all of that. We pass it through IBM Watson's transcription engine to get call transcripts or text, and then we treat each KPI as an NLP problem and solve it using machine learning. So ultimately, our results produce the same CSR scorecards as those developed by QA agents. To walk you through an example of how our models or QA agents evaluate calls, you can see in this transcript that the CSR starts the conversation without any introduction. And if that's a rule, it will affect his call scores. Similarly, he didn't perform any verification or authentication process and directly asked the customer for his PIN number, which is almost always never allowed. And then he informed the customer that he magically activated their card, even though he got an error of system failure, access denied on his portal. So this is an oversimplification, but I hope you get the point of this. So how does it all work in AI? Our typical development pipeline for KPIs includes first data collection, meaning annotating the scorecard for a call, as well as other dialogue management things. Next, all this data is then used to generate features from text, audios, and the consumer portal. After the data is prepped, there's usually a timeline for model selection, trying to find the best set of rules or ML models that solve the problem. And then finally, once something is deployed, we look into improvements through manual error review. Now, you probably noticed that some of these KPIs I showed, like empathy or active listening, these don't really have anything to do with Rasa, but the KPIs are their components called attributes that depend on the subject matter of the dialogues in a conversation. They could use a little help in dialogue management from Rasa. So that's where we use Rasa in our NLP engine or MLOps pipeline. And then there are other models that calculate other things that are not the focus of this presentation. Okay, so let's start off with the first step of our pipeline, that is data collection. We annotate our data for dialogue management through an open source API called Label Studio. The first thing that needs to be done and once a dialogue is transcribed and segmented by IBM Watson is to assign a speaker ID to that dialogue or even to parts of the audio, because the performance of anonymous speaker diarization from IBM Watson by default isn't really perfect, which is why this is kind of really needed. The next step is to select intents per dialogue. In our use case, we want to track intents from both speakers, so not just the usual customer or cardholder queries. And then since it's free speech, IBM Watson's sentence segmentation sometimes doesn't really segment sentences by intents. And so the usual use case is often multiple intents per dialogue. And to keep the data for intents separate from the calls themselves, we annotate spans of text per intent, and that helps us separate these intents training data later on for NLU training data prep. Okay, so after intents, we annotate entities, which are also spans. One thing to know here is that in the usual use case, you have a direct mapping of entity to slot. But in our case, since dialogues are very rarely having any context as to what a number, for example, may represent, we keep entities and slots or entity roles separated. And then we also have this category of parametric slots that require a further mapping of whether or not an entity value matches a parameter coming in from the database. So for example, for verification purposes, we want to match what the user provided with what's in the database, and that defines what the next CSR action should be. So finally, we also annotate data for our actions, which are call flows and attributes. Flows help us identify all the rules that might be applicable in certain portions of a call. And then attributes are the rules that may have failed in the call themselves, such as in here, the CSR revealed the correct date of birth to the customer instead of asking for it, which would be breaking up a policy in the customer's domain. Okay, so now that we have all our data annotated, which by the way, takes very long. I mean, for one call that lasts 6 minutes, it probably takes an hour to annotate everything, dialogue management plus others, to annotate all of these things for one call, which is why we usually use models to label them first, and also why we don't have a lot of human reviewed or annotated data available, but it's still sufficient. Okay, so after collecting data, we move on to feature selection. First thing, how do I add the speaker context to NLU? Well, the simple solution for that we found was just appending the correct speaker ID to the start of the sentence. This means that at the time of prediction, the speaker diarization model, we have a dependency on that running before Rasa and after IBM Watson transcription to proceed with NLU and core. Okay, next, as you can imagine, we don't always get perfect transcriptions. In fact, it's mostly wrong. Because of that, if we only had singular examples of incorrect transcriptions, we'd probably be lost. But luckily, IBM Watson provides us with a list of phonetically similar alternatives that we then use to generate multiple examples per dialogue for every intent as well as entities. And then for training data for Rasa Core, we use call conversations themselves as stories. In these stories, the actions are call flows and KPI attributes or rules, as discussed earlier. But currently, because of performance issues, we're only using Rasa Core for flow detection. Okay, so we have the data in the correct training data format, lots of samples and speaker context involved. Now we go into modeling. For intent detection, we implemented 3 models. Actually, I did a few more, but these are the best ones. The first one is a dense neural network that uses pre-trained embeddings from TensorFlow's Universal Sentence Encoder, and it performs multi-label classification for intents, which is different from what Rasa does. It treats every multi-intent instance as another class. Instead of predicting multiple intents at the same time, it does multi-class classification. Another model we used utilizes pre-trained embeddings from Facebook's Wave2-Vec2 speech-to-text transcription model that's connected to a recurrent neural network for intent classification. Its results are relatively bad, but not the worst, given it uses audio features for prediction. It was certainly the best, given best results, amongst all of the other audio-based models, which is why we still keep this. And then finally, we also used Rasa's sklearn model with pre-trained vectors from Distilbert, and its performance is really good, given that it's such a simple model to train. For entity recognition and slot filling, I first tried out Spacey's pre-trained vectors for NER with rule-based mappings based on current user, intent, and entity value for slots. It has a really poor coverage over entities, and the performance is, so-so. Next, we use conditional random fields from Rasa with the training on entity names, roles, and groups separately. We mapped slots to entity roles instead of entity names, and then used entity groups for tracking how much frame of a value was matched in a certain dialogue and how much of it is remaining, etc. One model that performed really well, but it takes really long to train and is still not in production, is Simple Transformers Conv-AI or Dialog GPT implementation. It uses customers' data, like parameter values, as the bot's personality, and the current dialogue history as context, and does predictions for slot tagging. This model is very accurately able to detect the frame of slots, as well as any updates made to them, because it's custom designed. Its responses is very custom. So this one works best, but it's still not on production for us. Finally, we have two types of actions, flows and attributes. We use Rasa's memoization policy for flows and custom implemented state machines for attributes. Our state machines have certain rules on intents, slots, current speaker, knowledge-based articles that are found in a dialogue, or customer sentiment, CSR sentiment, lots of things that ultimately predict the failure of KPI attributes. The problem with using state machines right now is that it's too much configuration and manual rule management that we're looking to improve with AI and more data, but right now it works pretty well. One methodology that we applied to improve results for intents and entities was semi-supervised learning. Semi-supervised learning is an approach to machine learning that combines a small amount of labeled data with a large amount of unlabeled data during training, and it falls between unsupervised and supervised learning. It's also called weak supervision. Its methodology goes like this. You first train a bunch of models that are weak learners on your labeled data, and then you train a meta learner on this labeled data using predictions from these weak learners. This meta learner then predicts its results on lots of unlabeled data that you can then use to train a final model and validate its performance on labeled data. Compare results against the true labels instead of the model produced labels on the unlabeled data. It's a bit confusing at first, but once you try it out, or you look this up, you'll find that it's actually a pretty simple concept. So using semi-supervised learning, we were able to implement our final Rasa diet plus Wave2Vec2 ensemble in the Snorkel API. It uses a stacking ensemble, which is just a logistic regression unit that's trained on the outputs of diet and Wave2Vec2. Which are the base learners in this case. And this final ensemble, though it takes kind of really long to train, it gives us the best results for intents and entities so far. Okay, so what's left? Well, there are further improvements that we're looking to add to our implementation. The first one would be to connect custom components with Rasa, as for slot tagging using Dialog GPT. We're also looking to do more annotations for attribute policy learning using Rasa Core for attribute predictions. We're looking to implement more models for more customers. Right now, we just have this one huge customer that has a lot of these use cases. There are around 300 attributes at the moment. which are constantly increasing. And then we're looking to include knowledge bases directly into dialogue management, which is something that we don't do right now. Neither knowledge-based management nor sentiment analysis is integrated into dialogue management, which is something that we're looking to do in the future. I wanted to mention that since May of 2021, I am no longer a part of the NLP team at I2C, so much of the credit for this project's deployment, success, and maintenance on production goes to my colleagues at I2C, as well as all our QAs and our management team. So great job, you guys, and good luck. Good luck with all the production issues that I left behind. I think it was a good time for me to run away, but yeah, great job, and yeah, good luck for the future. What do I do now? At Boomtown, I'm working on implementing bots using a Flow Builder UI, which can then be deployed on the customer's website. For assisting agents, we also offer knowledge-based suggestions and auto responses that helps them reply faster and even resolve cases automatically. Currently, I'm really looking forward to working on things like automating flow creation from real conversations directly, and even just giving users suggestions on how to build their flows, kind of like flow auto-completion or Rasa story auto-completion. And I'm also right now, like since last week, implementing Rasa into our Boomtown's bot platform. So hopefully I can present about it maybe next year. I'd say my new job is equally as exciting as my last one, but yeah, I definitely miss my last job as well. Yeah, that's it from my side. Thank you. And if you have any questions, I think we have time to discuss, but you can also reach out to me on LinkedIn.